David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Today's video covers the probability of independent events. So before we get into that and do some calculations, we need to define what we mean by independent events. So here we go. Two events, A and B, are independent if the occurrence of one does not affect the occurrence of the other. So let's tease that definition out a little bit by considering three pairs of events. The first one, rolling a 5 and flipping a head. That's a pair of events. Here is flipping two heads in a row. That's a pair of events, two coin flips. And the third one is when drawing two cards from a deck of standard cards, what is the probability that the second card is a spade? Now I want you to consider each of these three pairs of events and decide whether or not they are independent or dependent. So pause the video, do that, and come back. All right, the first event, rolling a 5 and flipping a heads. I've got a coin in one hand and a die in the other. Whatever happens on the coin does not affect what happens on the die. So these two are independent events. Second one, flipping two heads in a row, also independent. I flip it once, I flip it a second time. The first flip does not affect the second flip. Same thing. Now this one, they are not independent. Now if you don't see right away why that's the case, pause the video and think about that for just a minute. Okay, let's take a look. When drawing two cards, what's the probability that the second card is a spade? Now the first event will affect the second event. If we drew a spade in the first card, then the second card is going to have a slightly smaller chance of being a spade because we removed one spade from the deck. Otherwise, if the first card is not a spade, then the second card being a spade will have a slightly higher probability because there's more spades left in the deck. So this pair of events are not independent. All right, let's take a look at the product rule for independent events. It's pretty straightforward. If you're looking for the probability of the intersection of both events, that is the AND condition, the more restrictive one, where both events happen, then you just multiply the probability of event A times the probability of event B. That's it. So let's take a look at an example. What if event A is flip heads on a coin and event B is roll a 4 on a die? I want you to pause the video and calculate that probability. So here's what I get. Probability of flipping heads is 1/2. Probability of rolling a 4 is 1/6. There's only one 4 on the 6 sides. So we just multiply those two out and we get 1/12. Now I want you to dig back into one of our last lessons and draw up a sample space diagram in grid form and verify that that is correct. Okay, here's my grid. Pretty straightforward. Check it out. I've got my heads and my tails row. That's that. And then I've got my 1 through 6 on my die there. I'm calculating the probability of the intersection of both flipping heads and rolling a 4. That's A intersection B. And so that's this one here. That's a heads 4. So I've circled 1 out of the 12 possible outcomes. I get 1/12, and that's the same as this math. Now, if you have a prompt to write the sample space out, you're going to need to do that. But if you don't have the prompt and you understand the probabilities, this is a much quicker way to go. All right, let's do an example. And get used to these examples where you're picking objects out of one container and picking objects out of another container, and there's different amounts of different objects in each container. So in this case, we have 2 bags of marbles. The first bag has 3 reds and 2 whites. The second bag has 1 red and 4 whites. Okay? Now, it's sometimes helpful in a situation like this to draw a simple diagram that represents what you have going on. So here's my first bag, 3 reds, 2 whites. Here's my second bag, 1 red, 4 whites. All right, so we're going to do some probability calculations. I want you to figure out the probability of both reds. But before you do that, I want you to convert this into our notation that relates back to the product rule that you just got on the last board. So do that and then calculate your probability. Okay, so here's the notation. We're looking for the intersection where we get red from both bags. So it would be red intersection red. So that's it in notation. You should be used to going from here to here. This is descriptive. This is more concise and more mathematically expressed. So probability of both red is the probability of this bag red, which is 3 over 5, times the probability of this bag red, which is 1 over 5. That gets us a probability of 3/25. Now let's do one that's a little bit more tricky. Probability of 2 different colors. Now, here's the tricky part with that, is we can get that 2 ways. We could get a red-white, or we could get a white-red. So what you need to do is calculate both those probabilities and add them up. So pause the video and do just that. All right, let's see how you did. So I converted it into notation. We're adding the probabilities of the intersection between red-white and white-red. So that's my notation step. Now the probability of getting red first and white second is 3/5 times 4/5, plus the probability of getting white first and red second is 2/5 times 1/5. I did my math, and I get 14 out of 25. Okay, this one's even more tricky, and there's an easy way and a hard way. So I'm gonna just turn you loose on it, and let's see which way you come up with. The probability of at least one white. Okay, so there's actually 3 ways to get that, right? There's white-red, red-white, or white-white, because white counts. White, getting both white is at least one white. So go ahead, pause the video and do that math. All right, now let's see how you did. So what I did is I wrote my notation. We're looking for the intersection of white-red plus the intersection of red-white plus the intersection of white-white. So 3 probabilities to calculate. I went ahead and did my fractions here based on my diagram. I got my numbers, I added them up, and I get 22 over 25. And that indeed is the probability of getting at least one white. Now there's a nice and quick way that just involves a quick little critical thinking step. So if you didn't find the easy way, I want you to pause the video, look at this situation again, maybe scroll up to your notes because there's something there you can use. So here's the trick. There's one outcome that wasn't in this one, and that's 2 reds. At least one white covers 3 of the 4 possible outcomes. All the outcomes together add up to 1. So if we subtract the one outcome that's not represented here from 1, that will give us the probability of the other 3 combinations. So 1 minus the probability of red intersection red, or both red. So if you haven't done that, do that and come back. So if you remember, probability of both red was our first calculation there. So this is 1 minus 3/25, which ends up giving us 22/25, which is indeed the same answer. Both ways are fine. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.